so how's everyone doing? I am just going to plug in something right here, and I've got my slides. So there we go. So good morning. My name is Kerry Brand. I do lead the innovation activities at Plantronics. So Plantronics is a manufacturer of wearable technology for your ears. My job is to actually explore what's possible, not only on your head, but also looking forward for other body-worn devices, sensor technology. So I'm here today to share with you a bit of insights that we've had at Plantronics around wearable technology, around sensors, around building devices, because I think the wearable tech community is still small, and this is kind of an intimate setting, so I thought I would share with you just some of the insights that we've had. So if we look historically at technology, especially disruptive technologies that we've had, we've seen things start off not as a flash. You don't see, we don't have, for example, air transportation as we do today when it first started. It didn't instantaneously come into existence. But what we've seen with these major technology transitions that have made our lives better is that it's built upon very small pieces at a time. There was the invention of flight, right? But a lot's improved since, Kitty Hawk a long time ago. We've got engines now that are not piston-powered, but turbine-powered. We have materials instead of wood and fabric that are advanced composites that aircraft are assembled from. We've made better airplanes, but there's a lot of other pieces that go into that puzzle as well. There are things like the infrastructure, control towers, runways, ticketing systems. All of these systems are working together, and the innovations around that have been incremental. We've incrementally seen the emergence of a major industry. Now I'm going to map that to wearable technology. So with wearable tech, I think it's a lot. We've seen a couple of trajectories here, and I think we're at a precipice of change. Compute has gotten smaller and smaller, faster and cheaper. We're seeing computers that are, I can hold in my pocket now that once used to occupy the space of a room. This is a pretty fantastic thing, and it's pretty amazing. I'm amazed every day by the device that I just have in my hand. But we're also seeing the advent of connectivity, and connectivity to not only the voice networks, but to data networks. So the devices we carry are smaller, faster compute, but also able to reach out and connect to the internet at any point in time. So those two trends are happening today, and we're seeing that continue. But we've also got something else that's on the horizon, and that's wearables. And that's an interesting thing. It's kind of the convergence of very small devices that are very low powered, that have moderate compute, that can be worn on your body, in your clothing, and actually can have that connectivity to the cloud. So moving forward with this technology transition, if we look about 2020, let me make sure I got my clicker going here. 2020, we're going to see, I would say, hundreds of billions of devices that are going to be interconnected to each other, to the internet. And that's a lot of data, right? These devices that we're building contain data about ourselves. And we're going to be able to propagate that up. Now, that's very interesting, but it's also very chaotic. Today, my universe consists of a lot of these pieces, but they don't really talk to each other. They're very good at, this device is very good at keeping track of how much I've been moving around, but it's not really talking to, a Fitbit that I may be wearing or my headset. These devices don't talk to each other, but they talk to the cloud. So I think we're ready to see the unification of mass wearable technology and actually the emergence of an industry. And there's some enabling pillars to that. So when we think about wearable technology, we can think about the wearable device itself. So this is one of ours. This is our Voyager Legend. It's a wearable, but you could replace it with a bracelet. You could replace it with glass. You could replace it with whatever. It's just there to placehold. But the wearables that we're building today are getting smaller, and they're cheaper, and they're connected. And the reason they're connected is because we have devices that enable that. So there are three pillars that I think will drive the adoption of wearable tech. The first is connectivity, so being able to connect to the internet at any point in time, wherever you are on the face of the planet. The second piece is cloud compute. So when we build wearable devices, we really have to consider things like battery life. Can the device actually last an entire day? If so, does that mean, excuse me, if it's small, do we have enough battery power to make that happen? Or can we offload some of that compute? If we have connectivity to the cloud, we can stream data and compute up to the cloud and let bigger machines with more power take care of those tough problems, those tough number crunching problems, cleaning up the sensor data, which leads into the third piece of this, which is analytics. So if you have connectivity, you have virtual compute out there from the connectivity, it's very easy then to take that and scale it very large and analyze that data and make sense of it. And I think we'll be able to make sense of it not only for a company, not only for a select group of people, but for everybody. It's really about making the data personal to me. And I think wearable devices are going to be feeding that and actually bending that Internet of Things to me. So it's an Internet of everything. So at Plantronics, we view this as a stack. Our stack is really on the, I guess that would be on the left side of the, or on this side of the equation. But it's really about building the wearable technology that people love and wear. It's adding, so that's form factors, right? The ergonomics. If it's on your head, it needs to feel comfortable. It needs to be something you can wear all day. If it's on your wrist, same thing. There's some devices that are out there today. They're a great start, but they're not really comfortable. I get fatigued after wearing them for for a couple of hours. But building the wearable form factors and technology, adding the smart sensing capabilities. So it's not about throwing a bunch of sensors onto a piece of plastic and selling it. It's about picking and choosing the right sensors that actually address a customer or user need. And the last piece of that equation, when we're building devices, is software. So we can build very small, very discrete devices, but if you can't access them and integrate them into bigger, broader solutions, you're missing out. And you're missing out on this bigger ecosystem of things. So we believe that stack is something that we are focused on building with everyone in the community. But in addition to that, there's context. So taking things that are environmental, sensing in this room. Maybe there's Wi-Fi networks. Maybe there's Bluetooth smart beacons in this room. But being able to take the contextual information along with the sensing information that is on your body, feeding that up to the cloud and delivering those enhanced experiences. So this is kind of the equation for success that we see for wearable tech. Oops, let me try my clicker there. There we go. So what does that mean? So when you think about that equation and you apply it in a nuts and bolts manner, there's a couple of things. And we've seen some success with this today with products that we build that aren't prototypes that my team has built, but actually shipping products that we have in market today. We can signal things to systems like how close we are. Proximity is very important. I'll give you a use case. With one of our partners, Cisco Systems, we built a solution that takes proximity, it takes connected state, so it knows if you're on a mobile phone call or not, and we're able to actually walk into a building on your mobile phone, signal proximity with our device, and actually get the call transitioned and upscaled to video on your desktop. And we can do that because we have the APIs that allow us to integrate in. I think that's kind of a strategy when we're all building wearable tech, is to have those highly integratable APIs. We can do other things too. We can do presence based on sensing information. If I'm wearing the device, or if I put it on, being able to signal those events and feed those into a system so you can actually communicate presence. Also busyness. If I'm on a phone call, maybe my device is glowing a different color because I'm busy. But being able to signal virtual presence in a real world is another area for wearable tech. So this is the wheel, and I'm going to walk you through this. When we build devices at Plantronics, and we've been building them for quite some time, these are a lot of the elements that we consider in the design of a device. The first piece is sensors. As I said earlier, it's not about choosing, to put in the kitchen sink of sensing into a device. You have to take into consideration what problem you're trying to solve. Is it something that a user would actually use, or are you just doing it for the geek factor, which is kind of what I would do. I would throw a lot of sensors into a device just because I enjoy tinkering. But it's picking the smart sensors and then writing the algorithms on top of that. We're seeing a lot of chip manufacturers today that are coming with the algorithms already baked in. So it becomes very easy to integrate in the chips as they are with your own firmware and actually get a pretty good result. But the sensor piece is absolutely essential. Things to consider there also are power consumption. So when you're putting sensors into a device, how much power are you taking away from that battery? The second piece that we consider is applications. So building a device is great, but being able to take that information and surface it into applications, not just your own, but other applications, is essential. So when you're thinking about your device that you're building, think about the applications it's going to be touching and interacting with, and even the applications you haven't thought of. The third piece that we consider is essential is privacy. It's one thing for me to maybe share, my pedometer readings with the cloud, with others, but maybe it's something else to share my heart rate. I may only want to share that information with my doctor or my health insurance company. But those types of things need to be considered. It's like, if you're producing data, how are you producing it? Are you producing it in a secure way? Is policy coming into play here? And if so, what should be public and what should be private? It's an interesting problem we all have to tackle. The third, going down the wheel here, no numbering, power. So batteries, I think, are a bottleneck for a lot of small, discrete devices. Chipsets are becoming less power hungry, but at the same time, if I were to try and build a very small device with something like Wi-Fi, it becomes very difficult because it's power hungry. So when you're thinking about the device, you think about it holistically, you have to look at the power, and I think we've heard that a couple of times here, so it's not an unfamiliar theme. Interoperability. Not only device to hub or device to phone, device to laptop, but device to device. If we really want to achieve an internet of everything, everything has to talk to each other. And so how are all of these wearable devices that we're building today going to interoperate and communicate with each other? How is data going to get represented consistently? If I have a heart rate coming from my Adidas watch and I've got pedometer functionality coming from a Fitbit, are those two speaking the same language? They should be, because you can have a better, more enhanced experience. The developer platforms that we are thinking of and we've built are SDKs. So writing SDKs for mobile platforms, writing SDKs for the desktop environments, anything that will allow easy integration of your technology into the user's world. So development platforms are essential. Ergonomics. So I think we had a question yesterday. So how many people think that the winning wearable is going to be on your wrist? Oh, come on. That's it? Okay. How about on your ear or on your head? So things like glass aren't important. Okay, cool. What about on your belt? Okay. What about on your head, on your belt, on your wrist, on your feet, on... Wow, okay. Well, I think that ergonomic design is going to be essential, and I think there's a couple things. If it's not going to be in your clothing, it's going to be on your body. There's very limited real estate, and so, your head is a natural place for wearable technology. Your wrist, perhaps your waistline, and in your back. I think those are great areas, but they're going to be fought for. I think it's going to be getting the real estate on the person to where your technology is going to be where some of the big battles are fought. So I would say all of those areas are equally important. And you have to design, when you think about those areas, each one you have to design differently for it. At Plantronics, we have a wall of ears that actually, we take castings of people's ears. If one of our devices doesn't fit, we will take a casting and a mold of it. And we actually have in our ID area, our industrial design area, a standard distribution of ears. And it's kind of creepy because there are these kind of silicon ears that we've taken casts of, but it helps us determine how to fit the devices across a standard distribution of users. Now, if you do the same thing with wrists, with belt lines, with whatever, you have to really know the person's body that you're putting the device on. So ergonomics is essential. Connectivity. When we think of connectivity, it's not just Bluetooth. There's other radios out there. There's Bluetooth, Bluetooth Smart. There's DECT, which is what most cordless phones are operating off of. There's Wi-Fi. But each one of those types of connectivity technologies, and there's others out there, has its own power set of requirements, right? So if you're building a small device and it has to last all day long, well, putting a Wi-Fi radio in it today may not be the right design choice if you want small, all-day functionality. Maybe Bluetooth Low Energy is a better solution. But when you're building your technology, that is something you should be considering is how you're going to connect. How will you access the Internet of Everything? And the last piece is miniaturization. So at Plantronics, we've built some very, very small discrete devices. Our Bluetooth stereo headsets, which you can see at our booth, it's just a thin ribbon of circuitry with 2 earbuds that go in your ear, and that's the only wires it has. There's no connections. You know, it's using Bluetooth to stream your music. It's also got talk capability, so you can take phone calls on it. But to build that product, we had to design miniaturization in from the beginning. You can't just build something and then try to shrink it back down. It has to be actually engineered in first. It takes a lot of time, and it's very intensive. But the end result is very small, discrete devices. So these are, that's the wheel of considerations for you as you're approaching wearable tech. So what does that mean? So, you know, I've talked a little bit about the connectivity, the analytics, the ability to offload compute to the cloud. You know, from a new normal perspective, it's kind of interesting. I mean, I think I'll just ask you to expand your thinking here a little bit, and let's kind of venture forward, assuming that we have ubiquitous connectivity to the cloud, we have the data analytics, we have the wearable technology that can work all day long because the battery size has been solved. We can build very small devices with very dense batteries. I travel quite a bit. You know, if I had, let's say, maybe something on my wrist that was connected to the cloud, and maybe, you know, I've got my dad. He's getting on in age. I would really like to know how he's doing, but I travel quite a bit, so it's hard for me to call him all the time, especially when I'm on stage talking to folks like you. So it would be excellent if I could walk around in this new normal, and my dad, who's at home, he's got sensors on his body. Maybe he's got a pendant, maybe he's got a bracelet, maybe he's got clothing that is detecting, you know, heart rate, breathing. His bed could have sensors that actually say you're in your bed, you're off your bed. You know, toiletries could actually be wired so they know that they're being used. The refrigerator door, the TV, all of these things can be connected together and fed into the cloud. Now, the sensors individually don't really give you much of a picture of my dad and his life. But working together with analytics, we can start to identify patterns of what is normal, what is not normal. You know, my dad gets up at 9 in the morning. There's movement. He's off his bed. You know, the TV is turned on at a certain point in time. All of these things can we can develop some algorithms that can figure out those patterns. And if they deviate, I want to know about it. Not because I'm trying to snoop on my dad, but, you know, if he's living by himself, if he takes a spill, or if he's not in those normal boundaries, I want to know so I can reach out and see if he's okay. So assume that my dad doesn't get up at, you know, his normal bedtime, and he hasn't gotten out of bed for a couple of hours. I may get a notification on my device. It may vibrate, and it might turn yellow, saying, hey, something's wrong, you should check in with your dad. And I may, you know, at that point in time, if I'm just walking down the street, I want to just have that phone call because I'm concerned. When I do that, I may use a smartwatch to do that out dial. You know, I'll press the button, call dad. When my dad picks up, maybe he's groggy and I'm trying to talk to him, I want to have that conversation. And I want to have that conversation, but I want to have it not here. I want to have it here, right? I want to have a private conversation with my dad. It's okay if you hear me talking, but I don't want you hearing what my dad's saying, especially if I bridge in his physician. So being able to have privacy in conversations, notification here, but audio here, is essential in that use case. I think those are things we need to consider as we're approaching this new normal. It's not just one device, but it's the combination of devices working together to make things better for all of us. So I think from the Plantronics perspective, we've seen you know, several opportunities in the market for wearable tech. Fitness and wellness is a no-brainer. We've seen a lot of solutions for it. I think it's low-hanging fruit. Healthcare and medical, I've just given you an example of aging in place, where you can use wearable technology to let people live longer and more independently in their own homes. Industrial military use, we've seen examples with heads-up displays, relaying information, infotainment, gaming is a natural extension for wearables. Communications, being able to seamlessly transfer communications because of the technology on your body in between modalities, mobile to desktop to full immersion video experiences are all possible. So this is a great industry. It's a great time to be in because it is early. So I want to talk briefly about state of the art today. Plantronics has sold, our wearable devices, we've sold millions of them, so we're pretty familiar with selling wearable tech to folks. This one is one of our flagship Bluetooth models. This is the Voyager Legend. Today, this device has built into it 2 sensors, and we've actually been playing with sensor technology in wearable tech for probably the last 3 to 5 years. We've been putting them into shipping products. But this one has 2 capacitive sensors in it. It knows wear state. So if I'm putting the device on my ear, off my ear, those capacitive sensors will actually tell me that it's being worn or not. And we use it with a smart algorithm that we've written that actually allows us to, if your phone's ringing, regardless if it's on your desktop or your mobile phone, you put the device on, it answers the call because it knows it's being worn. So it's kind of built-in smarts into the device. We've also surfaced APIs. We have an SDK that's available today for developers to use free of charge that will allow you to integrate in and control the device from your desktop. One example that we've seen a lot of customers use in the enterprise is our devices can span 2 connections at the same time. So it can be connected to your phone, your tablet, your phone, your PC, whatever, but it can support 2 simultaneous connections. We've seen customers use it to surface mobile caller ID as your mobile phone's ringing and feed that into the cloud on your desktop. So you can pull up like a customer care record as your mobile phone is ringing. So we can use caller ID as a lookup that our device is kind of the hub between those modalities. But that is where we're at today. It's a fantastic product. We have that capability across our portfolio. I'm here today to talk about this device, and it looks an awful lot like this one here. But this device is something my team built. The exercise was twofold. A, how small can we shrink the sensor technology down, and B, what capabilities can we do with that small size? So we added a 9-axis sensing capability. It has an accelerometer, a gyroscope, a magnetometer. It also has the capacitive sensors that I spoke to earlier. But let me show you kind of what this does. So I'm going to move over to my next slide here, and I'm going to highlight this. So why don't we go ahead and switch over to the second video. All right. So there we go. I don't know if you've seen this in our booth, but so this device does have the capacitive sensors on it. So when I put it on, you'll see the wearing state has changed to hopefully wearing. There it goes. So we've got wearing. I've got tap detection. So if I tap on this device, or let me tap on it here. There we go. So tap detection. It's got free fall. So if I throw this device up in the air and catch it, you'll see, oops, I dropped it. You'll see a free fall event has actually occurred. So you can actually get the events from the device, and it's sturdy enough that it actually can take a free fall. The other thing that we've done with it, it's got a pedometer in it. So if I do this motion, you can actually see the steps will start to increase. So it recognizes that you're moving. Right. The other interesting thing is because it has 9-axis sensing capabilities is that we've taken it, and you saw a little bit of this last night during the demo, but let me shake it here. So we've added head orientation to it. Oops. There we go. Hold on. There we go. So up, down, left, right. We've also mashed it up with Google Street View. So you can actually do augmented experiences just using the device. So I'm feeding in head orientation along with the GPS. Okay, so that's what we've built as a concept, but go ahead and go back to the slides here. What we've done on top of that is that we've built a limited production run of these, and we've actually started to make these available to developers to actually innovate with. We have APIs for iOS, for Android, for Windows. And we have a new web property that we announced in August, and that was our pltlabs.com site. So if you're interested in actually hacking on one of these devices, you can visit us at pltlabs.com and sign up, because we've started to ship some of these out to a few folks. And speaking of that, I really wanted to focus on that this device is becoming more aware of itself. It's becoming more aware of integrating in. But we've taken this device to developer hacks. And I brought somebody from our Seattle Interactive hack up here to this conference to actually show you what is possible. We've had numerous hackathons that we've participated in. We've had lots of entrants that have won with our device. But at the Seattle Interactive conference this year, in the fall, we had Adam Smith Kipnis, who's coming up here. He and his team, Hack Couture, hacked this together in about, what was it? 18,
19 hours.
18, 19 hours. So pretty impressive. I'm going to click over the slide, or over to this slide here. So Adam, what did you do?
So what our team did was we were competing in this wearable computing hackathon, and our thoughts along the lines of wearable computing was how can we weave computing into the actual fabric of the things that we wear, and also leverage some of the great technology that was there available at the hackathon. So we built this headbang driven air guitar app, and we built it around the accelerometer detection that is available in the Plantronics headset.
Okay.
All right. So.
Very cool. And we're going to do a demo. So what did you write the application on? Did you use the iOS APIs that we built?
Yeah, we did. We used the algorithms that were there in the API that were available. And we also used this Raspberry Pi microcontroller.
Awesome.
Yeah.
And you built a sheath for it, too.
That's right. Yeah, so we actually had a fashion designer who was working with us, as well as an electrical engineer and some mobile developers. So right here, you can see it's just fabric that's detecting these different chords. And the idea is that when we built this, we thought, well, what's one of the first things that people learn how to do when they're playing guitar? Is they wanted to learn how to play the opening riff for Smoke on the Water. So, yes. So that's what I'm going to do right now. Yeah.
Go for it, man. Go for it. You're controlling the music here, the chords, and then
yep.
Where does the Plantronics wearable concept come into play for that?
Right. So each of these fingers, it bridges a circuit, and it's all the computing or all the circuitry is in the fabric, and it's connected over Wi-Fi to the iOS device, and the Plantronics device is paired with this. So a lot of the processing is happening here, and leveraging a lot of the algorithms that are in the chipset in the Plantronics device.
Got it.
Yeah.
Very cool. So the build was how long for this?
The build?
The build to actually make this?
Oh, yeah. Well, the first version, once again, was about like 18 or 19 hours. We've been working on a few stabilization things since then, and the Plantronics developers support has been fantastic. Working with you and Greg Rose, it's been great.
Fantastic. Well,
yeah.
Thank you so much for showing that.
Sure.
And can we get back to the slides here?
Yep.
And we'll wrap up. Just awesome. I love
right.
that thing. I just love it. Isn't that awesome? Awesome. All right. Thank you, Adam.
Yep.
Okay, so hopefully this was educational. We wanted to share with you just some of the, like I said, the insights that we've had. We are and will be continuing to participate in the wearable community. We build devices. We know a lot about making them very small, very powerful. But we really like to hear from you. So if you're really interested in experimenting like Adam and his team did, let us know. You can reach us at pltlabs.com. Drop us a line. We're really interested in engaging with all of you as we approach this wearable tech transition together. So thank you.